In this section we will learn how to multiply and divide rational expressions. Multiplying rational expressions. The product of two fractions is found by multiplying the numerators and the denominators respectively. So for instance, if you want to multiply P over Q by R over S, you simply multiply P and R and multiply Q and S. And this will work whether you are multiplying ratios of numbers or ratios of polynomials. Whether you're multiplying rational numbers or you're multiplying rational expressions. Example: 2 over 7 times 5 over 10 is equal to 2 times 5, 7 times 10, which is to avoid having extra terms, we get rid of the common terms, so we factor 10. 7 is prime, so 2 goes with 2, 5 with 5, so this is simply 1 over 7. Multiply this rational expression by this rational expression. So what happens is we multiply the numerators and we multiply the denominators. Now what we have is 9 over 3 is 3. P squared goes and P, we end up with only 1P in the numerator, and 1Q goes with 1Q. So what we are left with is 8P over Q. Okay. To do it in details, this is what we have. We have 8 times P times P times Q times 3 times 3. Okay, this is 9. There is no need to factorize 8. Okay, but if you do, it's going to be 2 to the power 3. And over here we have 3 times P times Q times Q. So 1 3 goes with 1 3, 1 Q with 1 Q, 1 P with 1 P. Okay, so what we have here is 2 to the power 3 is still the same, so it's 8. And we have 3 left here, so 3 times 8 is 24. P, okay, no more numbers in the denominator, but we still have a Q. Okay, so this is the right answer. So I might have forgotten about the 3 over here. Alright, multiply, then write in lowest terms. Multiply numerators, so we have 3P minus Q times Q. Okay, just to make sure I write the Q different from the 9. Alright, and you have P times 2 times P minus Q. P minus Q. Both have P minus Q, both the numerator and denominator, and these are the only common terms. So what's left is 3Q over 2P. Alright. Multiply numerators. So we have numerators multiplied, and multiply denominators, and this is what we have. Now, we factorize x squared plus 7x plus 10. Two numbers, their product is 10 and their sum is 7. 2 and 5. So x plus 2, x plus 5. Okay, this will give us x squared, 5x, 2x is 7x, plus 10. Okay, this is what we learned to do before. So this is this piece. This. Now, this one can be factored by taking 6 out. Okay, 6 times x, 6 times minus 1. So you have this. Again, here you can take 3 out. So you have 3x, which is this, 6, which is this. And again, here you can factor this out. Two numbers whose product is minus 15 and whose sum is 2. Okay, so minus 3 and 5. Minus 3x plus 5x will give us 2x. So will give us this term. And minus 3 times 5 will give us the minus 15. This is exactly what we learned before when we did factorization. Common terms. This goes with this. This goes with this. And 6 goes with 3, and we're left with 2. Okay, we still have to factorize 6. 6 equals 2 times 3. So in the numerator, the 6 became 2. We still have x minus 1. In the denominator, we still have x minus 3. Now, dividing rational expressions. Now, dividing rational expressions is very easy once we understand multiplying rational expressions. So we have to practice very good to make sure we understand how to perform multiplying rational expressions fast and easy. And the reason why I say that, because we can turn dividing rational expressions into multiplying rational expressions. Okay, if you want to divide this rational expression by r over s, this is the same as multiplying the rational expression p over q by the reciprocal of r over s. So basically we just flip this. R over s becomes s over r, and the problem of dividing becomes a problem of multiplying. Now we know how to multiply rational expressions, and we're done. So again, let me say it using different letters. A over b divided by c over d is the same as a over b multiplied by d over c. Alright, divide. We change this into multiplication and we flip this. So 5 over 16 becomes 16 over 5. Now this is equal to 16 over 4 is 4, so we have 3 times 4 over 5. This is 12 over 5. Dividing this by this, we flip this and we multiply. So what we have is 9 becomes 3 times 3, 3p plus 4, there is no common factor here, divided by 3p plus 4, 6 is 2 times 3 times p cubed. There is no use of factoring this because there is no p in here. So what we have is 3 goes with 3, 3p plus 4 goes with 3p plus 4, and we're left with 3 in the numerator, in the denominator 2 times p cubed. Okay, dividing by this, we flip it, becomes 8 over 10 ab squared. So this is equal to 5 is prime, a times a is a squared, b is b, and 8 is 2 times 2 times 2. In the numerator we have 2, 10 is 2 times 5 times a times b times b. 5 goes with 5, 1a with 1a, 1b with 1b, 2 2's with 2 2's, and we're left with, in the numerator you have 2 and a, 2a. In the denominator we have only b. Dividing this by this, we flip this and we have this. Alright, now this is equal to, in the numerator we have 4, 4 is 2 times 2, x plus 3 times 4x squared plus 1 minus 1. Okay, this actually this is equal to x squared minus 1, but 1 is, can think of it as 1 squared. So this is a squared minus b squared, which is a minus b, a plus b, where a is 2x and b is 1. So this is equal a minus b, a plus b, 2x minus 1, 2x plus 1. So that's the numerator. The denominator, we have 2x plus 1. This is minus. Remember, minus could be anywhere because this is multiplication. Okay, minus, you have x times x, and you have times x plus 3. We don't need this anymore. Now let's see common factors that cancel out. Nothing happens to the 2's. X plus 1 goes with x plus 1. 2x plus 1, 2x plus 1. And that's it. This is equal. In the numerator we have 4 into 2x minus 1 over x squared. Remember, the minus could go anywhere. So minus x squared. No common terms anymore. Okay. Divide this by this. First we change it into a problem of multiplication. AB minus a squared over a squared minus 1 times a squared plus 2a plus 1 a minus b. So this becomes this. Alright, factorizing. A common factor between this and this is a. So in the numerator we have a, b minus a minus b is this. This, if you remember, okay, we just did that trick. It's a squared minus 1, which is also 1 squared. So a minus 1, a plus 1. So this is a minus 1, a plus 1. This is a plus 1 squared, because this is a squared minus 2a times 1 plus 1 squared. So this is a plus 1 squared. Now let's see what we can cancel out. Nothing. Is that the case? A minus 1, a plus 1, a plus 1, a plus 1. Well, actually, yes, we cannot cancel anything. Nothing cancels out. B minus a. Alright, we can simplify though. B minus a, okay, remember B minus a is equal minus a minus b. So this is equal minus a minus b, a minus b. And over here we have a plus 1 times a plus 1. And we have a plus 1, 3 of them, right? So we have 3 of them. And we have a minus 1. Okay, finally, the numerator becomes minus a minus b squared, a plus 1 cubed, a minus 1. This is a summary guideline multiplying or dividing rational expressions.